Um, it's such a pleasure and honor to welcome Minjun Son, Dr. Minjun Son at Chan Zuckerberg in Chicago to Living Histories to tell us about how he went from being a puzzle lover to a biophysicist, aka Living Histories.
Okay. Yeah, it's thanks for the invitation. It's an honor to present myself. And so yeah, I'm going to introduce how I become interested in biology from the physicist point of view. Oh, sorry. Hold on. Yeah. So when I was a kid, I mean, I grew up in Korea, Busan in Korea, and I spent I was born there. I yeah, until like a second year of college. Then I transferred to the US in the middle of undergraduate. So, but anyway, when I was in childhood, I loved like many games, like board games or Sudoku, especially like these Chinese chess. So whenever I had some kind of allowance, I went to the like a store to buy some like different board games and or something like that. And also another thing I was interested in is building something like a Legos. And or not just Legos, but I also printed out something like a paper craft and then do the origami and these kind of things. Uh, these are the what I was really fascinated about. And sorry, why it's not working? Yeah,
Click the mouse. Yep.
yeah, okay. And so as I grew up, and so there's another game that I actually played a lot. The picture you see right now is Go Moku. It looks very similar to Go, but it's actually different. And the rules are quite simple, but there's a lot of like in-depth strategy with this game. And another good thing about this game is that you don't have to remove any stone. So as long as you have a paper with some kind of like cross lines, and as long as you have a pen with a different color, then you can always do it with your friends, even during the class. So I don't know, I think I spent good portion, maybe 2 or 3 years of middle school and high school sitting back in the class so the teacher couldn't see me and I was playing this game with the friends around me. And yeah, I was quite good at this, and I love this game, and I loved how like a very simple law or rule can evolve into something very complex at the end. So among the classes that I learned, I love the math and science. I love the fact that I mean it was so satisfying to find only one possible answer from the questions, but by the same reason, I didn't like the literature at all. And for me, the literature was something like this shown in the picture. I mean, the like author says something, but from my point of view, there are many different possible like explanation of it, or there are many different ways to understand it. And how can you actually find the one that's right out of all? So I mean, usually it's like a multiple choices questions, and there are five choices, and I cross out some impossible ones, and then now there are only two possible answers left, and then chances are 50% now. So in all the classes, I got very good scores in math and sciences, but literature, I mean, I did a fairly okay, but it was not really, I was not really good at it. And another thing I was obsessed with was circuitry, like or radio circuits in general. I was very curious how the audio or like pictures can be transferred through like electromagnetic waves. How it can, like it's invisible, right? So there's some kind of way to communicate, even though you are very far away to send this kind of information. I was really like when I was in like elementary school, I really wondered how it worked. And during the middle school, I tried to develop it. But at the time, there was no internet. And the only the thing that I could find was like from the textbook. And then usually these books for children didn't really explain in details. They just showed a rough circuit diagram or pictures, just explain how, I mean, what kind of outcome it gave and not how it worked. They didn't really explain this. So when I was trying to first build these circuits, I was like when I look at the circuits, why is it necessary to have a coils? Let's just put a straight like a wire with some wire, and then only make a coil here. Why is it necessary to have a capacitor? Just make a better, just a straight line. In other words, I had no idea of how the magnetic induction works. And when I look at the capacitor, and when I look at this picture, these large two plates look like antenna that send a signal. And I didn't know it was capacitor, so I just made this one really huge so that signal can transfer farther. And then it took 3 years. It was only when I finished like physics 2 when I was in high school that I actually kind of get an idea of how it worked and made this setup working successfully. So looking back, I think I was very fascinated by finding very like a simple or clear solution from a very complex problems. I mean, especially, I think this is also very related to the biology. If you look at the biology, although seemingly it seems work, but if you look at in details, it's very complex. There are so many inputs and parameters, they interplay with each other. Yeah, somehow it works. I mean, from the DNA, the cell interprets this, and then from the like single like embryo, very complex frog or like a creatures can develop from. And yeah, and also I think I mean I heard this from colleagues, but I think that many physicists or physics major at least encountered the special relativity theory when they were in like middle school or high school, and then they were inspired by that, and then they wanted to become like Einstein. And I think I was one of them too. So combining all this, I gradually thinking about becoming a physicist. And then also at that time, physics was the subject that I think I didn't have to spend too much time. Like when I was studying like history or others, I had to spend a lot of time to memorize or I don't know, like to comprehend all of that. But physics, it seems like I just need to know the equations. Then everything just falls from there. So I like this simplicity, and then I also like the fact that I have some other times to do something else too when I'm doing the physics. And so I joined the physics program in the University of Florida, and I started learning something advanced classes, and these are some of the subjects that I loved. So statistical mechanics, linear algebra, and I mean, as you can imagine, like the advanced physics one, or electronic like circuit classes, and also I didn't really think that time it was that interesting. But when I learned it, it was kind of shocking to me. There is a chaos theory. I mean, chaos theory kind of tells you that even though the outcome or what's on the surface looks very complicated and stochastic, there's actually is governed by very small change in the initial states. And that initial small state change, following the simple rules, can create these very diverse outcomes. So I was really enjoyed learning this. And one of the things that shook me at the time really a lot was joining the military. So I was a Korean citizen. I have to serve in the military. So I served in the military for 2.5 years in a DMZ against North Korea. And I'm not sure how it helped me to become a physicist or a better scientist, but it taught me a lot about like human nature or I don't know how to put it, like how to overcome the hardships, I guess. But what really affected me more was that so I have to go this I had to do this service in the middle of undergraduate. So when I came back, it was almost like 3 years after, and almost everyone that I knew, all the friends that I had already left the town, they already left the college. So I was pretty much alone when I initially came back to US. And I started so I started reading some like philosophy books, like especially Schopenhauer, and how to enjoy being yourself and alone. And so after spending 2 years and then getting the bachelor degree, I was a bit I don't know, sick of living in the US. I kind of wanted to go back to Korea. And so for the first year, during the first year of my PhD, I literally joined the PhD so that I can still make money and then study some time to join the medical school in Korea. But at the end of the first year, I have to choose at least one what kind of a lab I would join. And so I went to one of the professors I talked to was Steve Hagen, who was a biophysicist in University of Florida. And then he showed me this. So biology actually acts like a circuit. So there are many, I mean, it works in terms of proteins or genes, mRNA, but they're all connected and one induces the other and inhibits the other. So it forms a very complex network, which is just like electronic circuits. And also it's very stochastic. So this shows the fingerprints of twins. And you can see that even though they're twins, their fingerprints are different. These twin cats have different patterns. So even though they are driven by same DNA and same like genetic circuits, the outcome can be different as well. So this is what really made me think about pursuing really seriously about the PhD and then joining the biophysics. And so I did, and so what I'm doing right now is kind of in line with that. So I'm trying to look at how signal spreads through the tissue and in a very complex environments. So I'm showing you the simulation of some mammalian cells where the stimulus is injected, and there's some like signaling molecules cells are secreting and spreading. And as you can see, this is a very stochastic. Cells are turning on and off, although in general, it spreads farther away. So I'm trying to interpret this. So using the wavelet transformation, I'm trying to see if there's any like a hidden frequency, or there's a hidden information in this very stochastic response. And using the information theory, I'm trying to analyze how much information can be transferred through this network. And I had to spend a lot of time developing the tools, doing the engineering, because many biological data that I wanted to gather was not actually measured. So I'm also developing some tools, high throughput microfluidics to monitor the spatial temporal like tissue response in real time. And lastly, I want to thank to these people, my family, who are always supporting me. And I forgot to put their names, but yeah, my PhD PI Steve Hagen and postdoc PI Savas Tai and some other PIs, especially Alex Hoffman from UCLA, and my lab mates Andrew Wang, and also Dr. Shanna Kelly for giving me lots of opportunities and then understanding, I mean, supporting me throughout my career right now. And we also we have an internship program in like CZ BioHub. So if you're interested in doing 3 months of like research in the BioHub, please contact this person shown below. Thank you.
Thank you so much, Minjun, for a fantastic talk. Slides were to hang, yeah, slides were flawless. You know, I was torn between listening to you and reading everything on your slides. I invite audience to send me more questions, but I will start with one, which is the game that you mentioned early on, which made your school year super fun.
Yeah,
It had
yeah.
simple rules and could give a variety of complex outcomes, and that's what drew you to it, is what you said. Then you showed us this beautiful equation and told us what you loved about it was that it had one correct answer. In this interplay between simplicity and complexity, where do you find yourself now? And with the benefit of hindsight, what in your childhood made you decide to go towards biological systems?
Um, yeah, yeah, good question. I guess I didn't like the fact that biology is just the facts. It's like it's a list of like a findings in an encyclopedia, and then there's it's very difficult to connect from one phenomenon to another phenomenon. There are many things affecting it, and but at the same time, I feel like there's some kind of a, I mean, for example, in the immune response, when your skin get infected with a bacteria, yeah, although it's very stochastic, each person has a different response. But most of the times, they heal, they fight successfully, and they heal themselves. So I feel like there's some kind of robust process hidden behind all this. And yeah, I'm trying to find like a one, I mean, for example, E&M, I think it's all driven by like Coulomb's law and Maxwell's equation. And I was very inspired to find these like simple laws in like a cell-to-cell signaling.
music to my ears.
Yeah.
Uh, but to wrap up, I will take a question from the audience. One of the early career people in the audience wants to know what specifically you learned from your PhD. If you could do that in a few seconds. Thank you so much.
What did I learn during the class or during research work? I guess
Up to
anything,
you.
right?
Up to
Yeah.
you.
Yeah, during the class, I'm not sure how much all of them were useful, but statistical mechanics were, I think, were very useful, like information theory and concepts of entropy, finding the energy states. I think I'm literally using that right now to apply some of my research. And for the research, I think I had to start from the biology. During the undergraduate, I only took the biology one class, and then I actually wasn't thinking about doing biology at all when I joined the graduate school. So I had to learn. I mean, when I first write a paragraph, I couldn't distinguish what the difference between the mRNA and DNA, and my PI was so shocked that he asked me to go and join this, I don't know, class, so I think I spent like 1 or 2 years like learn biology and then also learn about the engineering, like how to make the microfluidic devices. So during my PhD, I think yeah, for the 4 or 5 years, more than half is pretty much developing doing the engineering and learning. And I think I spent only 1.5 years to do what I actually want to do, like a simulation and cell circuits, and then find the bimodality and so on. And yeah, I think that's how my graduate school was.
Thank you again, Minjun, on behalf of the audience. And in the interest of time, I'm closing the recording.